we now are moving on to sine law. Okay, take notes. Before we were working with 90-degree angle triangles. Okay, now we're working with any triangle. And sine law is a law that applies to all triangles, whether or not it has a 90-degree angle. Works on all triangles. SOHCAHTOA only worked on 90-degree angles. Okay, that's why we're working with sine law presently. Because what if we have a triangle we need information about a triangle that doesn't have 90-degree angle? So that's where sine law comes in. And what is sine law? It just says that there's a ratio between this angle and this side. And when we have that ratio, that's equal to the same ratio as the sine of this angle and this side. And it's equal to the same ratio as the sine of C with its opposite side. That's all that this entire thing, sine law, says. Okay, how do we use that? Okay, so let's work with examples now. Now, let's say I have this angle, this triangle. There's no 90 degrees anywhere. And let's say I want this value of my angle C. Well, I have to find the ratio between sine of C and 8 is the same ratio as the sine of 65 divided by 9. That's equal to sine of C over 8. Now this is a number, this is a number, and this is a number. And we can certainly find that by finding the inverse sine of C. Anyway, let's work at it. Sine of 65, put that into the calculator, we get 0.906. Divided by 9, that stays the same. And that continues to equal that. Next step. Well, let's just solve that. Just do that division. It's equal to approximately 0.1. It's also equal to sine over 8. Multiply both sides by 8. Sine of C equals 0.8. That's equal to 0.8. So we want the inverse sine of 0.8. We have already used that in our calculator. So we find that C equals 53 degrees. Now, what did we find out? We found out the angle opposite of a side. When we don't have a 90 degree, we were able to find information about our triangle. We had incomplete information. We found some information like angle C from incomplete information from a triangle with no 90 degree angle. Before we were able to find because we used SOHCAHTOA with a 90 degree angle, but now we can use it with any triangle. Let's look at example 2. How do we do it? Do it in the exact same way. Let's move this out of here. Okay, so how do we solve it? Well, we have a sine of 45 over 20. That ratio is going to be the same ratio as if I take sine of 70 over C. And now this is a number, this is a number, this is a number. Right? Don't think sine here is a variable. That's a very common mistake for people. It's just a number. It is just a number. Okay, so how do we solve it? Well, sine of 45 is that over 20. This stays the same. Our next step, we got that 0.03535 comes from here, equals sine of 70 ends up being 0.94. Put that in your calculator and verify. Now, C becomes equal to 26.57. How did that come about? Well, there's lots of algebraic ways we can do, but that becomes 0.03535. C equals 0.94. So then C becomes 0.94 divided by 0.03535. And that's equal to 26.57. And that's it. We found the opposite side. Now let's use this to find out our word problems. We have an airplane. It's flying between two tracking stations. So an airplane's in the sky. Let's see if I can draw an airplane. Whoops. Whatever, it's fine. Yeah, why not? The tracking stations are 35 kilometers apart. So I have a tracking station. How does a tracking station look? I don't know. Let's just say it looks like this. Another tracking station over here. And that's my tracking station. They're 35 kilometers apart. Draw a line 35 kilometers apart. By the way, you should be trying to do this on your own before you find my solution. Station A measures an angle of 51 degrees between the ground and the plane. Okay, let's call this station A. And that angle is 51 degrees. Station B measures an angle of 39. Let's call that station B. And let's measure 39 between the ground and the plane. Calculate the distance from the plane to each tracking station. Oh, this is not 35 degrees. This is 35 meters or kilometers. Let's call 35 kilometers. Okay, so we're gonna have to find out what the distance is between this distance. Let's call this distance B, right? Because that's between B and the plane. Let's call this distance A because that's between A and the plane. And let's call this distance, we might as well call it C. And this is angle C. By the way, can we figure out angle C? Do we have any opposite sides? Well, let's look at sine ratio. Sine of 51 over B, right? Take that with its opposite side, equals sine of 39 over A, okay, equals sine of whatever this angle is over 35. What is that angle, by the way? We need an angle or we need a side. But we can find the angle because we have two angles. We can find the third angle is C is just equal to 180 minus 51 minus 39. Well, that's just equal to 180 minus 90, which is equal to 90. So sine of 90 over 35 equals sine of 39 over A. So let's look at this first. And we'll find A using it. So sine of 90 degrees over 35 equals sine of 39 degrees over A. Let's solve for A. What's sine of 90 over 35? So A, let's just solve these values. Sine of 39 over 35, whoops. Clear. Sine of 39, is that right? No. Yeah, sine of 39 times 35, we're going to cross multiply, times 35 equals sine of, okay, so that's 22. All right, sine of 90 degrees times A equals 35 times 35 sine of 39 degrees. Well, A times sine of 90 equals 22. Divide by sine of 90. Well, what's 22 divided by sine of 90? Divided by, whoops. Answer divided by sine of 90. Oh, it looks like it didn't change at all because sine of 90 is probably equal to 1. A is equal to 22. So that's equal to 22. So the plane is 22 kilometers away from the, station A. Now let's look at the other one. Sine of 51 degrees over B is equal to sine of 90 degrees over 35. So let's cross multiply. B times sine of 90, that is equal to 35 times sine of 51 degrees. So what's 35 times sine of 51? 35 times sine of 51 equals 27.2. B times sine of 90 degrees equals 27.2. What's sine of 90 anyway? Sine of 90 happens to be equal to 1. So B equals 27.2. So we have our solution, equals 27.2. So the plane is 27.2 kilometers from station B and 22 kilometers away from station A. Okay, and that's how far away the planes are from the tracking station. Example 3, 2 planes are flying towards an airport from opposite sides. So I have an airport, and let's just pretend our airport's like a cube. Airport. And I have a plane. Let's just call that plane 1. And let's call that plane 2. Let's just call it a point. The airport control tower records the angle of elevation of plane A to be 43 degrees. Oh, well, we'll call it plane A and plane B. How about that? And plane A is, from this, we got a flat surface here. Let's just pretend it's on a flat surface. And the angle of elevation to plane A is 43 degrees. And the angle of elevation to plane B is 59 degrees. It records distance to plane A as 1589 and the distance to plane B as 1643 meters. And it wants to know how far apart these planes are. Well, our first guess is to know, well, first we're going to assume that they're at the same level from the ground. And our first guess is to say that there's a few ways to do it, first of all. First of all, we got to determine what this angle is. And that's equal to 180 minus 43 minus 59. Let's do that math. 180, clear. 180 minus what? 43 minus 59. Minus 43 minus 59. That's equal to 78. So let's actually erase. And it's equal to 78. Oops. Great. 70. Why do I keep writing 9? 78 degrees. Okay. So let's see if we can solve that. By the way, what is this angle right here? Well, because this is parallel to the ground, we have a Z pattern. And that means that this side is equal to 43 degrees. This side is equal to 59 degrees because of our Z pattern. Which means we can use our sine law. So sine of 78, let's just call that D. Sine of 78 degrees over D is equal to, let's use this side. Let's use the ratio between these sides. Sine of 43 degrees over 16 43. Let's see if we can solve that. What's sine of 43? So that means D times, let's cross multiply, times sine of 43 degrees equals 1643 times sine of 78 degrees. So let's do that math. 1643, clear. 1643 times sine of 78. And that's equal to 1607. So D sine of 43 degrees equals 1607. Divide everything by sine of 43. By the way, sine of 43 is just a number, right? So it's just dividing by some number. D equals 1607 over sine of 43. Divided by, whoops, answer, divided by what? Sine of 43. Two, 3, 5, 6. D equals 2356. Therefore, the planes are 2, 3, 5, 6 meters apart. And that's your final answer. Okay, that's it. Thank you.